In this video, I'm going to give you a hands-on demo on how to provision Red Hat OpenShift on IBM Cloud and some of the deployment options you have. So, from the IBM Cloud catalog, you can either select Create Resource or navigate on the left and select Kubernetes. Click on Create Cluster and select OpenShift. You are now given a set of options that let you customize the deployment of OpenShift. So first thing, you can select if you want to deploy 3.x or 4.x. In this case, I'm going to select the latest version, 4.3. And you can select what type of subscription or license entitlement you're going to use for your deployment. In this case, you can say, I have a entitlement that I'm going to use for this worker pool, or you can purchase an entitlement directly from IBM Cloud. In this case, I'm going to use my existing OCP entitlement, and I'm going to select the infrastructure. You can deploy on Classic or on VPC. With VPC, you get a greater choice in terms of isolation. With Classic, you currently have a number of additional deployment options, such as bare metal for your worker nodes. Looking at the location, you can choose a geography. So you want to choose something that's usually close to where your workload will be consumed. Since I'm located in Ireland, I'm going to select Europe. You can also select if you want to have high availability as part of multi-zone regions. So when you select multi-zone, your cluster will be spread across 3 or more data centers within your availability zone. Here's an example with London. You can choose to have your worker nodes and your master nodes spread across 3 or more data centers. So in this case, I'm going to select London 04, 05, and 02. And I'm going to deploy worker nodes per data center. So 3 worker nodes across each of these data centers will be deployed, a total of 9 worker nodes. So in this case, if London 05, the entire data center goes down, I still have 2 data centers. My masters are still going to be in quorum, and because I have a considerable number of worker nodes which will exceed my workload can just fail over, and I still have a working cluster and working applications. If I'm doing this for development and test, I can reduce my costs by selecting single zone as my availability, and then I can pick an individual data center. So let's say I want to deploy into London 06, and I can select the number of worker nodes that will be deployed. As you can see here, I'm deploying in a single zone, and I'm selecting a number of 2 worker zones per data center. This is actually the minimum number of worker nodes that you need to have a successful or a fully working OpenShift cluster. So in this case, I will have one master, I will have 2 worker nodes, and they will all be deployed in London 06. As you can see, I will incur a cost of 54 cents an hour for this configuration, although I can change the flavor. So if I want to use a dedicated bare metal, I'm giving the option of selecting from the list of bare metal servers. I can also select virtual shared. So this is a virtual shared environment where we're using, hypervisor. On the hypervisor, we're placing the worker node, but the bare metal system might be shared with other customers. Or I can use a virtual dedicated system where I have full access to the machine on which the hypervisor is placed, but I'm getting a VM on top of it. So this is managed by IBM Cloud, but that entire host is not shared with any other customer. So in this case, I'm going to go with the default option, but keep in mind that you do have a number of options here where you can deploy onto different configurations. Once I have everything in place, you need to remember to give your cluster a meaningful name. So looking at the top of the list, you'll see all of the options, OpenShift, entitlement, infrastructure, location, worker pool, and resource details. So I'm going to call it OCP4, just to give it a meaningful name here. Okay, so now that everything is in place, I'm going to hit the create button and see the cluster get created by IBM Cloud. My cluster is already creating. As you can see, you are given instructions on how you can access your cluster. You can access your cluster to the OpenShift Web Console. In this case, you can just push a button here and you will be redirected to the console. And you can also access your cluster using the command line. If you don't have the command line installed, you can also use the IBM Cloud IDT installer, which will install, OpenShift Console, kubectl, and all necessary commands on your system. So this command will work both on Linux or on macOS. If you're on Windows, you can use a different installer, or you can install on the Linux subsystem. After your cluster is provisioned, you can also choose to enable a continuous delivery toolchain, so you can integrate it with IBM Cloud continuous delivery under the DevOps system. So you can deploy applications, from your Git repository or from your code repository directly onto OpenShift while using the IBM continuous delivery framework. Alternatively, you can enable an operator for Tecton pipelines, the OpenShift pipelines operator, and that gives you a different option for provisioning and using continuous deployment. You can also use Jenkins, which is integrated with the OpenShift container platform, so you have the choice to deploy your applications in a way in which you and your developers are familiar with. You also have a number of add-ons that you can enable, so you can use static routes, you can enable the diagnostic and debug tool from IBM, or you can enable a Kubernetes terminal so you can manage the cluster directly from your browser. In terms of management capabilities, you'll also see that you have the option to create storage pools and to scale your cluster up and down based on storage pools or number of worker nodes. So you're able to say, hey, I want to have a couple more worker nodes added onto my cluster or removed, then you can do this through this interface. You're also able to take a number of actions, such as updating the version of your cluster, so you can do a rolling upgrade, you can upgrade your master, you can upgrade your worker nodes. But keep in mind as you're doing these upgrades that if you haven't deployed sufficient number of worker nodes, or if you haven't deployed into a multi-zone region, you might incur some downtime when you're performing this upgrade. Otherwise, if you've deployed into a multi-zone region and have sufficient worker nodes, you can actually make this a seamless activity where your applications will be gracefully moved onto another worker node and you will not incur any downtime. You can also monitor the state of your cluster. As you can see here, we're still preparing the cluster information. So once the cluster is going to be in a normal state, you'll see all of this turn green. That's it for now. We're going to come back once the cluster has finished provisioning in about 10 minutes. My cluster has finished provisioning and it's in a normal state. Let's explore some of the changes in the overview page. As you can see, our master is showing as ready. The worker nodes are showing as healthy. And if I explore further into worker nodes, I can see both worker nodes are in a state of normal. Looking at the worker pool, I can also see that I have 2 out of 2 declared workers. So let's talk about accessing our cluster. As you can see, we have 2 main options to access the cluster. One is to use the OpenShift console from the CLI, and we can get started by installing the tools. You can also get access to console by clicking on IBM Cloud Shell, so you don't have to actually install these tools locally. And the second option is going to be through the OpenShift Web Console. So let's explore that in a bit of detail. So let's access the OpenShift console. And after clicking OpenShift console, you'll notice that we're already logged in using identity and access management with our IBM Cloud user. So there is single sign-on between IBM Cloud and the OpenShift console. And you will notice we have version 4.3.2. So let's explore some of the main areas of the OpenShift console. The first thing to keep in mind is the view. So you have an administrator view and you have a developer view. So let's take a quick look at the developer view to see the difference. Developer views let you provision applications, create them from Git, so source to image, from container images, from a catalog, from a Dockerfile, or define them from resources or a database. And you're mainly focusing on application deployment topics. An administrator view gives you a lot more access into the management areas of your cluster. So looking at the main dashboard page, you will notice we have 2 nodes, and we have 77 pods deployed, which is actually the OpenShift master and a number of operators which help manage your cluster. We've also been given 20 storage classes available by default, so we're going to explore this one as well. And we have one PVC set up for our cluster. So let's take a look at some of these items here. So first, you'll see the number of CPUs that we have available. As you can remember, we have 2 nodes, each of 4 vCPU each, as well as the file system and memory information, so we can monitor our cluster from here. And we can take a look at the nodes, pods, storage, and PVCs in the inventory. So let's explore the worker nodes. You'll notice we have 2 worker nodes, and these actually match the ones that we have within our IBM Cloud console. Going back to the main dashboard, let's take a look at the pods that we have running. And I'm just going to sort these by the namespace we're running in. So we have some in the Calico system. This is our software-defined network. So we have a number of pods that are running for our software-defined network. We have a number of pods which manage your cluster from an IBM Cloud perspective and integrated with IBM Cloud. And you can see these are in the IBM system namespace. So this is what NS means here. P means pod. If you look at this, you'll see it's a replica set. So these pods are actually replicated across the cluster. And they're deployed onto nodes. So as you can see here, the nodes on which these are deployed onto. Then we have cube system. And then we have a number of operators like the cluster tuning operator. So this is part of the operating framework, and it actually automates the actions of managing your cluster for you. Then you have the OpenShift Console, which also runs on OpenShift, as you can imagine. It's the system I'm using to currently access the system. We have a DNS registry, and we have a number of pods for the image registry where images are stored. The OpenShift Ingress, which manages load balancing in incoming connections across pods and does a couple of filtering for the connections. And we also have a number of items for OpenShift Marketplace, monitoring, and a few other items. So going back to the main dashboard, we also see we have storage classes. So storage classes are connected to IBM Cloud, and they give you tiers. So you have bronze or gold or silver, and these let our applications persist their data onto persistent storage, which is related to the storage class here. So let's take a look at one of these storage classes that are defined. They're defined with the IBM Cloud Block Storage plugin, as you can see here. And if you take a look at the YAML configuration, you will see that this is a ext4 file system on top of Endurance storage. So there is some level of automation which helps you manage these storage classes for you. Going back to the main dashboard, I'm going to take a look at the PVC. PVC is a persistent volume claim. It's basically when you attach something to a persistent volume. So we can actually see that we have a persistent volume claim. So we're using one of these storage classes. We have 100 gigabyte assigned for the OpenShift image registry. So we are persisting the images that are placed onto our cluster, but we will need to use more of these persistent volume claims as we start developing applications and we have a need for data persistence. So going back to the dashboard, you're also able to see the current events. So if anything is happening on your cluster, you can take a look at the activity log and think of the event streams as a time database, right? So things are coming in at specific times, and you have specific events. When you upgrade your cluster, you'll see all the events here. When you deploy an application, you'll see all the events specific to that here, and you're able to filter events based on their source, their destination, their category. So you can take a look at error events, for example. You'll see a number of error events as your cluster got initially provisioned and not everything was started. And once everything starts up, some of these events will be cleared as they're able to find the necessary information. You also have events of type info, which is things like I'm starting and stopping, or in deleting and creating a container, things of that nature. So now that we've explored the dashboard, let's take a look at some of these other sections. One of the interesting sections here is going to be the operator hub, right? Here is where you can deploy software that comes in either from Red Hat or from the community, which has various levels of automation in place. So anything from basic install, where this is similar to a Helm chart, it installs a software onto OpenShift, all the way to autopilot. So with autopilot, everything is fully managed for you. So if you deploy Portworx Enterprise for storage or the IBM Liberty operator, everything is including installation, configuration, management, backup, high availability, resiliency is automated. The steps that a system administrator or an operations engineer would typically perform are part of the operator automation, and this is done through frameworks such as Go or Ansible to perform the actual automation steps. Moving down, you have the section for workloads, where you can see the system, the pods that are running in your system, in your cluster at this moment, and then you have deployments and deployment configs, where you can see how your applications are actually deployed. You can see your stateful sets, you can see your secrets. Obviously, I'm not going to show you any of the secrets because that's not actually a good practice. So moving down the list, I'm going to take a look at some of the config maps, cron jobs, network configuration, so you can see your services and routes, your storage, your build option, your monitoring, so you can take a look at alerts, for example, or metrics, or the monitoring dashboard. So if you take a look at the monitoring dashboard, you can log in with OpenShift, and you'll get even more information out of this. So you can monitor, for example, let me just authorize permissions here so I can take a look at the monitoring dashboard. And as you can see, this is based on the open source Grafana project, so you can create and manage your own dashboards. So let's take a look at cluster information, right? So you can see CPU utilization, requests and limits, and data source. These are coming in from Prometheus. So if you need more information on Grafana, you can go to their website and see how this works. But the main advantage with OpenShift is that all of these dashboards are created for you. So all the information on monitoring and managing your cluster is already pre-built, and it's fully integrated with OpenShift. Okay, so let's close this and continue to explore some of the options we have here. User management lets you create users, groups, or service accounts. If you want to integrate, for example, specific tools, with OpenShift, you can create a service account. And then you can go to cluster administration and perform various operations on your cluster. So one thing that you probably want to do is you want to create a namespace. I see deploy applications, and you want to enforce resource quotas and limit ranges on those namespaces. So let's say we create a namespace, for developers. We're not going to go around and let developers consume all of the resources in our cluster. So I've quickly switched to the developer view just to introduce some of the concepts of these namespaces. So as you can see here in the developer view, I can look at the topology for anything specific to a namespace. So if I click on all projects, you can see the topology of everything that's deployed onto my cluster. If I look at the IBM certificate store, for example, there's no workloads found at present. If I take a look at OpenShift, again, I cannot see the workloads in this space. So as you explore, you'll see different topologies for the specific projects or namespaces. Projects and namespaces provide you with isolation. So you can isolate workloads from each other, and you can also perform and impose various quotas and limits on these projects. So if you want to deploy an application, you can say first create a project, and let's deploy a project. Let's call it data science. So let's say this is going to be my data science project. I'm going to call it data science project, space for developers to deploy data science applications. So I'm going to say data project science development. So I'm going to call it data science dev just to give it some additional naming. And once I'm in the data science dev project, I can create my workload. and you can use something called source to image, and you just point it at the Git repository, or you can create it from an existing container, or you can create a workload from the catalog. So just to explore some of the main deployment options, I'm going to select here from catalog. I'm going to take a look at things like middleware, and you'll see a lot of Red Hat middleware present within the catalog. Or I can take a look at options for CI/CD. You can deploy things like Jenkins. Software, you can deploy Redis. Databases, you have MongoDB. You can deploy a lot of these things through the developer catalog. Now, you might also want to take a look at the operator framework. So instead of deploying an application and managing it ourselves, we have the option of going to the operator hub and get the operator for MongoDB, and this will turn it into a fully managed application instead of using the application here. So going back, I'm going to go back to the main page to deploy an application, and in the next steps, I'm going to show you how you can deploy Jupyter Notebook starting from a Git repository. Let's take a look at deploying Jupyter Lab from a Dockerfile. Here we have a very simple Dockerfile within our Git repository. As you can see, it starts from a universal base image 8, so a RHEL 8 container from Red Hat, with Python 3.6 already installed, and it installs Jupyter Lab using Python pip. It also exposes port 8888 on all of the IPs the system is listening on. So this build will simply install Jupyter Lab and expose port 8888. Going back in my topology view, I'm going to select from Dockerfile. I'm going to give it the URL to my repository, which contains the Dockerfile, and specify the correct path. And I'm going to ensure the container port is the port on which my application will be listening. So it's the one inside the container. I'll also give it an application name. So I'm just going to call it Jupyter Lab, and I'm going to use a name that will be given to associated resources. I'm going to select if I want to have a deployment or a deployment config. In this case, I just want to use a simple deployment, so I can have declarative updates for pods and replicas. And I'm going to create a route to the application, which exposes my application externally, so I can just access it using a link. Once I click create, you will notice this showing up into my topology view. And if I click it, I get additional information. So if you look at Jupyter Lab, you'll see here on the left-hand side, I have a build running. You also get information on the deployment, the fact that it's coming in from Git, and you'll get information from the URL itself. So that's the URL for my application. So let's take a look at the Jupyter Lab application as it's currently being deployed. I've switched to the resources tab, so I can see the build is currently running, and I can see it's exposing the right port, and I'm just going to click on view logs so I can see the image being built. I scrolled all the way to the top, and I can see it start by cloning the Git repository. Then it runs a Docker or Podman or an image build to turn this container into an image. So to turn this Docker specification into a container image. So the first thing it will do is use the from image. It will pull this from access.redhat.com, and then it will perform the steps that I have in my Dockerfile to install Jupyter Lab. Once all the dependencies in Jupyter Lab is installed, it will expose port 888 in the container specification, and then it will push the image to the container registry. So you can see here, I'm actually using the integrated image registry within OpenShift, and the image push is now successful. So if I go back to the topology view, I can see that right now the pod is actually running, the build is complete. And if I take a look at the logs, I'm able to access Jupyter Lab. In the logs, you'll also find a token. So in this case, I don't have a password. I didn't set up any secrets or anything like that for my application, but I can access it using the token, which is generated only within this console. Once I log in with a token, so I'm going to select Open URL. I'm going to provide a token. I'm also able to log in and set a new password. So looking here, I'm going to say friend the world. And as you can see, we have a fully working system. Now, keep in mind that this is a ephemeral system, right? I didn't set up any persistent storage. I'm not saving the data anywhere. So once this container terminates, the file that I have here is going to disappear. So as we look at our application deployment options, some of the next things that we will learn how to do is to set up persistent storage or to use secrets so we can have more, reliable application deployments. But just looking here at the application deployment tab, if you look at the overview, you'll also notice that we have one pod running. So one of the beauties of OpenShift is that you can easily scale your workload. So if I want to have 2 pods or if I want to have 4 pods running, I can just click a button here and it will scale to the desired number of pods. Now, depending on the application, you will also want to make sure that you have the proper backing systems or that the application is actually able to communicate and you understand what's going on in terms of how this application is sharing its state internally. That's it for our demo today. We're going to go into some additional options on how you can use the more advanced features of OpenShift to persist storage or to configure secrets or to take advantage of some of the integration options with IBM Cloud in future lessons.